Hi, welcome to another episode of Conversations on Modern Farming. My name's Steve Savage. I am an agricultural scientist, actually a plant pathologist. I study diseases of plants, but I've been broadly involved with agriculture for a long time. And this podcast is a place where I tell some of the stories that I've learned over the past several decades of working in agriculture. I'll be interviewing some very interesting people and just trying to tell the story of modern agriculture. My guest today is Dr. Lynn Sosnowski, and she has a PhD in the field of weed science. And she posts on Twitter under the title Cereal Weed Killer, spelled C-E-R-E-A-L. And so we'll unpack a little bit about what all of that could mean. And I'll ask Lynn to tell you more about her background, but currently she lives up in Wenatchee, Washington, and works for Washington State University. So Lynn, I'm guessing that most people who are going to listen to this have never met a weed scientist. So maybe you could tell us a little bit about what that means and some of the places that you've worked in your career so far.
Well, okay. A weed scientist is just what it sounds like. It's a scientist who studies weeds, and not the weeds that are now legal in Washington State, but rather those pest plants that we find in our gardens, on our roadsides, in fields. And specifically, it's an actual discipline of study in, plant science, agronomy departments, and agricultural colleges, where we're focused on identifying weeds, learning about weed control practices, but it encompasses so much more than that. Ecology, genetics, statistics, biochemistry, agronomy, whatnot. It's a sub-discipline that's focused on the study of weeds and how they interact with our different environments, whether they be very man-made environments like a lawn or a farmer's field, or more natural environments, say where we might have invasive species entering. As far as myself, with respect to where I've been and what I've done, I got my PhD in weed science at Ohio State University, and it was a lab and field training. And then I've actually had the wonderful pleasure of working in different institutions around the United States, the University of Wisconsin-Madison, the University of Georgia in Tifton, Georgia, University of California, Davis, and now here at Washington State University. And I've done lots of different projects, from studying the biology and ecology of herbicide-resistant weed species, evaluating control strategies for these species, both chemical and non-chemicals, evaluating replacements for different herbicides and fumigants as they go off market, evaluating crop safety in response to weed control measures, and really just a lot of different varied studies and a lot of different varied systems.
That's great, Lynn. I appreciate that. And I think it's kind of special, actually, that you have seen weeds in all these different parts of the country. I think that gives you some real perspective. So tell me, what makes a weed a weed? Can any plant be a weed, or are some plants more weedy than others?
I guess, firstly, it's going to depend on how you want to define a weed, right? Mm-hmm. Any plant, that's in a place where you don't want it, some sort of undesirable plant in a given situation can be considered a weed. And so we're looking at any plant that's going to require some action to prevent it from affecting like an economy or an environment or human or animal health. But that kind of encompasses a lot of plant species depending on the situation you're talking about.
Right.
Often we'll focus on exotic species as being weeds, those weeds that come from a different part of the world. But native species in our own country or region can be weedy too if they're not in a very desirable place. With respect to what makes a plant a weed, there's been a lot of talk about characteristics that kind of define weeds. And there are traits that are more common with the plants that we consider to be weeds, pervasive, negative species, such as producing a lot of seed or growing very rapidly and developing under a lot of different extreme conditions, being dispersed readily, whether it's moving, seeds moving in the air or with animals, the ability to have seeds germinate throughout an entire growing season so that the species is always competing with a crop. They're, considered extremely competitive. They get out of the ground early, they get up and they grow quickly, and, they capture resources and use them more efficiently. So although weeds can probably apply to any plant that simply annoys us, there are traits that are associated with plants that tend to be more commonly considered weeds amongst a wide variety of growers or ranchers or, natural areas managers, gardeners, etc.
Right. So, part of it comes down to a human definition, depending on how it affects some human goal, right?
Oh, absolutely. And that's the bottom line, whether our goal is producing a viable crop or aesthetics, something that breaks up a sight line or interferes with a view or grows along a path that could cause a rash like poison ivy. So it definitely comes down to the human opinion of the plant, but again, there are very definite traits that seem to be associated with plants that we're generally unhappy with.
So there are weeds and there are weeds, and it depends a little bit on the setting. So in the case of farmers in particular, you've mentioned some of the problems weeds can cause, but what are some of the ones that tend to be the biggest problem for a farmer?
So the weed species that are the biggest problems for our farmers? Well, for right now, I would argue the species that's on everyone's mind throughout the Southeast, the Mid-South, the Midwest is Palmer amaranth. It's a particularly fast-growing species that produces a lot of seed that's really highly competitive with a lot of the crops that we grow, including cotton and peanuts and soybeans and corn. It's actually an example of a native species. It's native to the southwestern United States and northern Mexico, to the desert environment, but it's rapidly expanded its habitat. And it's developed resistance to a number of herbicides, in particular glyphosate, which is sometimes better known as Roundup, as that's one of the more popular trade names. So it's causing a lot of problems for growers. It's really gone out of hand in a lot of different environments. And, there's a lot of effort being put towards reducing the population numbers, preventing the development of additional resistance, and making those infected systems sustainable again. Right.
So to get it right, it's Palmer amaranth, right?
Yeah, Amaranthus palmeri, Palmer amaranth. It's been around for a long time, but it really kind of came to the forefront of most weed scientists' minds in 2005 when we discovered the first glyphosate-resistant populations in Georgia. We've got glyphosate resistance and ALS resistance and resistance to some other herbicides in various populations throughout the United States, and we're seeing more and more problematic Palmer amaranth populations springing up beyond just the southeast where it started or the southwest where it's native. We've got populations that are now really developing up through the Corn Belt and are causing problems. And that's probably one of the top weeds, but there are weed scientists and growers who don't have that problem to deal with yet. And they'll say kochia is the biggest problem. Andrew Kniss at Wyoming would say kochia. Some other growers would say horseweed. My tomato growers back in California would say field bindweed. So there's a lot of species out there causing a lot of problems.
So you've mentioned, certainly herbicides, and that's a very important part of controlling weeds, but what are some of the other ways that people have always done or still do manage weeds?
Well, yeah. So, a lot of times when we talk weed science, the first thing that everyone thinks of is herbicides. But, our synthetic herbicides in the grand scheme of agriculture are really a relatively new development. Only since, the 1950s, really, since we've had, products commercialized. So we do use, and I would never deny it, we do use herbicides, a lot of herbicides for the control of weeds, because they tend to be very effective. But we do use other strategies. There's mechanical and physical control strategies, certainly. Tillage, cultivation, hand removal of weeds from systems. There's a lot of work with respect to physical removal that's being done with automated robotic technology. If you look at some of the research that's being done by Steve Fenimore at UC Davis, he's been evaluating robotic weed control technologies for lettuce and leafy greens, and then hoping to be able to spin that technology into processing tomatoes. There's also mulches, whether they're plastic or living via cover crops, that can really physically obstruct weeds, act as barriers to germination or emergence. There's a lot of cultural control practices out there, such as maybe changing your row spacing to make your crop more competitive, to shade out or exclude weeds, changing a planting date to avoid particularly troublesome species. For instance, if you have a species that germinates early in the spring, changing the planting date so that you can manage the weed and then plant your crop without having, the potential for competitive interactions. We can rotate our crops and choose our crops to enhance the competitiveness of a system and exclude weeds. And sanitation and exclusion are big practices, making sure that if you're buying seed to plant, that it's certified weed-free, removing weeds before they set seed and contribute to the seed bank, cleaning equipment before you change fields to avoid spreading weeds, and choosing fields that are more free of weeds, particularly if you have a crop that's less competitive or more sensitive. But then again, there's always scouting and education, identifying problems and, addressing those problems early. And there's even scientists who are looking at biological measures for weed control, whether they're studying allelopathy or looking at weed seed pathogenesis or weed seed predation. So there's a lot of different strategies that people can use, and there's a lot of different strategies that are being explored out there beyond simply using synthetic herbicides for weed control.
That's great. I appreciate that. And so it's really a multi-front battle.
It should be a multi-front battle.
Right.
That's I think what any weed scientist would tell you is that we need to diversify our strategies, and integrate as many different techniques as are applicable or allowable in a system as we can, because the more that we can diversify, the more, I guess you could say, we keep the weeds on their toes, right? We keep shifting the environment, and we make it a bit more difficult to let any one weed or any one type of weed become established in the system.
That's great. And really that's true in even insect and disease control. The whole idea of the bigger, broader, mixed around toolbox is pretty much their answer.
Absolutely. Any good weed scientist worth their salt is going to be preaching to make sure your toolbox is as diversified as possible if you want to effectively control weeds. Of course, as economically as possible. There's diversifying, and then there's diversifying that's not economically feasible because of the cost associated with it. So it's a balancing act, but we need to do as best we can to really minimize the impact of weeds.
That's great. Now, I think these days, not that many people are actually actively involved with weeds. A lot of people don't even have a yard that they take care of. So, but maybe the first time most people have heard of the idea of a resistant weed would be a weed that has become resistant to a herbicide, particularly maybe it became resistant to Roundup. But are there a couple good examples of where weeds effectively have sort of become resistant to some other kind of more traditional way of doing weed control?
That's a really good question. And that's one thing I really like to point out to growers that I work with, or there are other people that, I talk about weed science to, is that anything that we do in agriculture is a selection pressure that is going to drive population shifts and community shifts in the weed communities. So basically what I mean is that, for whatever we do, whatever action we take, we have a reaction in our weed communities. So for instance, like the adoption of reduced tillage can change our weed spectrum and has changed our weed spectrum in a lot of systems, including an increase in the number of perennials that we see in those systems, or species that germinate from very shallow depths, or wind dispersed species that blow in, like horseweed, that'll germinate on the soil surface. Reduced tillage plus the adoption of drip irrigation in processing tomatoes allowed for the development of field bindweed, which is a deep-rooted perennial, to become a dominant weed species in the system. Barnyard grass is become a crop mimic and is adapted so that its appearance actually mimics that of rice. And it's avoided being removed by hand weeding actions. And there's dwarf forms of some weeds in cereal crops that allows them to avoid being broke out by harvesting machinery. Same thing with grasses that have prostrate habits in, lawns where we have a mowing being done. So we'll select for weeds that have herbicide resistance if we don't diversify the herbicides that we use or incorporate our herbicides into a more diverse program. But we can select for weeds if we use any kind of strategy too much. We will select for species that are adapted to those conditions. So we need to, as much as we can, as much as will be either physically allowed in the system or economically allowed in the system, diversify our strategies to reduce that potential for selecting for one species or one type of growth habit that can really thrive in that setting.
So from what you're saying, it doesn't sound to me like there's much danger of not needing weed scientists forever.
There was a quote that I saw once where someone in the very early ages of the synthetic herbicide era said, well, I can't imagine that we're going to have weed problems, in 10 or 20 years. We'll be good. But it's proven not to be the case, that we do need weed scientists. Weeds are kind of, don't want to say they're a step ahead of us, but they adapt, and they adapt to anything that we throw at them. We have species that will have strategies to avoid the timing of our tillage, or infrequent enough tillage will survive and regrow quickly and become established. I think we're going to need weed scientists for a bit longer yet.
Well, I'm glad that you'll be one of them, Lane, and I really appreciate your taking the time to talk to us today and help us get up to a little bit more to speed on weeds.
Oh, it was my pleasure, and I hope I answered any questions that you had, and I hope I can continue to answer weed science questions in the future.
That's right. And I know on Twitter you go by the name of Serial Weed Killer, but are there blogs or something people could follow you on as well?
Actually, yes. Right now, I have a personal blog that I've gotten started at the WordPress site. It's actually called Mary Stem's blog. but not meristem, like a plant grows meristem, but MERRYSTEMS.
I like it.
Meristem's blog. And as I get established at Washington State University, I hope to have a greater electronic footprint through that university, with the commodities that I'm going to be working with.
Well, that's great. I'm sure that the grower community and the forestry community and everybody appreciates your work there, and hopefully the only ones who won't will be the weeds.
Ditto.
All right. Thanks, Lynn.